Hi students, the next part we are going to look at the group 7 elements, which is also known as the halogens. So we are looking at your fluorine, chlorine, bromine, etc. So recall that they exist as diatomic, 2 atoms molecules. Okay, so fluorine is group 7, 7 outer electron, and you share 1 electron with the other fluorine atom to achieve noble gas configuration. Okay, so when I melt or when I boil fluorine, I am not breaking this strong covalent bond with the shared electrons. I am actually breaking the weak intermolecular forces. So this is an imaginary attraction between one molecule and the next molecule. So weak INFOA between the molecules. Okay, so these will attribute to some of the physical properties that my halogens have. Right, the first one, they all exist as diatomic molecules, as explained previously. And then there's some physical trends down group 7 that we have to know. Okay, so the first trend is the color intensity. It will increase down the group. So fluorine is pale yellow. Some schools say it's colorless. Chlorine is yellow-green. Bromine is reddish-brown. And iodine is violet or black. So you can see that the color becomes darker down the group. Okay, it has low melting point. So they have simple covalent structure, weak intermolecular forces of attraction between the molecules. So I need very little amount, low amount of energy is needed to overcome these weak intermolecular forces. This leads to low melting point, low boiling point. And since it's low melting point, low boiling point, it is usually gas or liquid at room temperature and pressure. Okay, as the size increase down the group due to increased shell. So period 1, I got 1 shell. Period 2, I got 2 shells. Fluorine is in period 2, 2 shells. Chlorine is in period 3, 3 shells. So the size increased down the group due to increasing shell. There will be stronger intermolecular forces of attraction. Okay, why? Due to increased size and mass down the group. So as a result, there's stronger attraction, right? Melting point and boiling point increases down the group. So these intermolecular forces of attraction is like your magnetic attraction. Okay, they are not physical bonds, they are just an attraction. And then it's like magnet. So if I have a small magnet, the attraction is quite weak. But if my magnet gets bigger, the attraction becomes stronger. So as the atoms or the molecule size increases down the group due to increasing shell, the attraction forces become stronger. So this will lead to higher melting point and boiling point. And as a result of this, the state of your group 7 halogens change from gas to liquid to solid. Iodine and below is solid. Okay, how is it related to these chemical properties of your group 7 elements? So halogens will tend to form halides by gaining 1 electron to achieve noble gas configuration. So IDE is the ion, which is the halides. Okay, reactivity decreased down the group from fluorine, chlorine, bromine, iodine. So fluorine is the most reactive, followed by chlorine. Okay, this is opposite of my metal reactivity series. So how do we explain this? Right, so same thing, down the group. Radius increase, size increase due to increasing shell. So electrons are added to this outer shell to form negative ions. So group 7, they are non-metals, they will form negative ions. So I am trying to add electrons. So for example, my fluorine, okay, there's 2 shells, there's 2 electrons, and then followed by 7 electrons. I am trying to add electrons into fluorine. When they react to form compounds. So they are trying to add the electrons inside. So there is higher inner shielding effect or higher repulsion by the inner electrons. So if I compare fluorine with chlorine, chlorine is 2, 8, and that's 7. So 2, 8, and 7. Right, so when I try to add the electrons inside, there are more negative electrons inside. So there are more negative electrons inside chlorine as compared to fluorine, right? So it is harder to add these electrons into chlorine to form Cl minus. Why? Due to the inner repulsion, or we call inner shielding effect. All right, so it's harder to add the electrons in, it's harder for them to react, and therefore my fluorine is more reactive than chlorine. Okay, another very common reaction that your halogens undergo is called the displacement reaction. So the more reactive halogen will displace the less reactive halogen from aqueous solution of the ions. Okay, so chlorine, let's look at this equation over here. I have chlorine and Ki, right? So same with as always when we write chemical equations, right? We take the positive, kick out the positive. So same idea over here, the negative, which is my Cl2, is going to kick out the I minus. All right, so remember, let's look at the reactivity again first, right? My fluorine, chlorine, bromine, and iodine. So fluorine is more reactive, this is more reactive. Chlorine is more reactive than iodine, right? So this is more reactive, you can go and kick the iodide out. Okay, so step-by-step explanation, how do we write it to get the full marks? Chlorine gas is more reactive than iodine. All right, so this first statement, I'm comparing the reactivity of my halogens. Okay, so it can displace the iodide because I'm kicking out the I minus. This is the ion, so the ion will end with IDE. Okay, so it can displace the iodide ion to form iodine, right? So when my I minus is being kicked out, it forms I2. All right, so this is what we write to explain why does this displacement reaction take place, okay? Step 1, the element is more reactive than the element. So this more reactive element can displace the iodide because it's kicking the I minus in the compound. And when you kick it out, it forms iodine. So be careful, don't use the terms interchangeably. Okay, sometimes they may ask us, what do we observe? So this over here is our observation. So qualitative analysis, QA, we learn about colored compounds, colored ions. We have your copper 2, iron 2, iron 3. So potassium, this is colorless solution, and then it turns brown due to iodine. So recall, right, group 7, color increases down the group. This is colorless, yellow, green, red, brown, violet, and black. So this one turns violet and black or brown for iodine. Okay, bromine, in this second reaction that we are going to consider, we have bromine and KCl. So let's look at bromine and KCl. Obviously, my chlorine is more reactive than bromine. So explanation, bromine is less reactive than chlorine. It cannot displace the chloride ion from solution. So there is no reaction.